Hypotheses. Hypotheses. Huh? It's your notes. If you got room on the same page, that's fine. I won't talk about hypotheses though. So we said there was a little bit of a problem with our understanding of hypotheses. It's simply an educated guess, right? That didn't quite work for us. Y'all showed me it doesn't work, right? Okay, you're arguing that it doesn't work. So what we need is a way, sort of the training wheels for you guys, so you can write a good hypothesis with a little bit of a little structure to help you. Okay. So let's go back to what we did yesterday in lab. Now, I got some good news and some bad news. Now the good news is that the best fit line, well, I drew one with the best fit line a while ago. What did I do with that? Oh well, the best fit line we said for this data went like this, right? Actually, that's wrong. I mean, that's what the data shows. That's what we go with. That's what your results should have said. But your data should have actually sloped down. I don't want to write an hypothesis based on faulty data. Okay? So some of you didn't do a very good job in your lab, or we would have had a better set of data. Let's see. I left this for some other classes. All right. This set of data actually gives us a better trend. This is from a different class. That's what it probably should have done, something like that. So what we should have had when we analyzed our data was a best fit line that did something like this. Okay? That makes more sense. Because I want to talk about hypotheses, I want to make sure my model fits what the data should be doing, because otherwise my mind's just gone. Okay? It's going to just blow my mind. All right? So we've got to help me out here, and Mr. Tedder doesn't go crazy. All right? Fair enough? All right. So based on, and look, you can't lie about the data. When you turn in your work last night, you have to analyze what your data said. That's what I want you to do. That's what scientists do. They analyze their data. They don't make data do something that doesn't do. You can't do that. That would be sometimes called massaging the data. All right? It's lying. It's an ethical violation. We want to go with what the data actually shows. But because I know a little about what should be going on, I want to make sure we're talking about the right thing. Okay? Fair enough? All right? And it's going to help you too, because I want to help you. I want to let you guys help me figure out a model. All right? So, hypotheses. We always put our independent variable down here, independent variable down here. So, if I change the temperature, what's going to happen up here? It's going to change. If this goes up, that's going to go down. Does that make sense? I don't see a lot of people shaking their head up and down. Does that not make sense? Yeah. It does make sense. I see more heads now. Okay. If this is increasing, this has to go down. Right? Got it? So we can say that if I increase, so what I can do is I can make predictions now. Based on this information, I can make predictions that if I increase the temperature of water, it's going to decrease the density of that water. Does that make sense? That's an argument. And that is the basis behind a testable hypothesis. So if I were thinking ahead of time, I think as I increase the temperature of the water, the density should go down. I have an hypothesis. Before I did this testing yesterday, I could have written that hypothesis and used this to find out if I was right. Does that make sense? All right. So what we want to do with an hypothesis, we always want to write it in an if-then form. If-then form. You can also write it or call it cause and effect. How does this cause that? If I do this, then that will happen. That's our form. It's a simplified form. Okay, there are hypotheses that don't follow this pattern, but this is our training wheels to get us started. Okay? Got that? All right. If what? And then what? Well, the if part then should become the independent variable. If I change, and then I'm going to describe what I think my independent variable is going to be. If I change and describe what the independent variable I expect to be, then dependent variable will, and what will it do? You have to fill that in, okay? Does that make sense? That's the general form of a good hypothesis, at least at this level, for right now. Got it? Training wheels. All right? We've progressed past the tricycle. We're on the training wheels with the bicycle now, okay? Got it? Tricycle was just educated guess. Now we're going to move past that. All right? Okay. There's really a little bit of a problem here. You know what? What did we say those hypotheses had to be based on? A model. There's no model here. We need a model. Need a model. What argument could we make that would explain, let's use this example here, what model could we come up with that would explain why, as the temperature increases, the density decreases? Let's brainstorm. Help me out here. Let's brainstorm. Rose. Let's brainstorm. Rose, are you part of that specious argument I made a while ago about why people lay down in my class and go to sleep? Huh? All right. Well, let's sit up so I know. All right. All right. Huh? Okay. So let's brainstorm a little bit. What happens when you heat stuff up? It expands. Why does it expand? Huh? Why does it expand? Now we're getting down to models here. What are the molecules doing? They're moving around. So if they move around faster, does that make them expand? Okay, they bounce off each other harder, they're going to move further apart on average. Good. That would be a model that might explain why the density would decrease. Why would the density decrease if the molecules are moving further apart? More space in between them? That's what he said. Okay. Why would more space in between them decrease the density?
Because the density is like how much.
What did we compare yesterday when we calculated density? What were the two measurements we compared yesterday to calculate density? Mass and volume. Okay? So if the volume, if we have one chunk of stuff, a space that doesn't change, if the molecules are further apart, we have to have fewer of them in that space. Right? Fewer molecules means lower mass. That makes sense? We got a model. We got a model. We got a way of explaining why this line goes down. Huh?
Amen.
All right, so let's see if we can put it together here. We want a model to go right in here. Then because, and this is where we're going to put the model in there. Okay, because we're going to put our model right in there. Okay. All right. I'm going to help you out here. I'm going to help you try to put it together. You help me, I'm going to help you, okay? That's right. I'm going to give you an hypothesis that might fit what I would expect to happen in this lab we did yesterday. Assuming we were making this hypothesis up before we did the lab, okay? All right. If I change the temperature of water, let's say if I increase the temperature of water, okay? If I increase the temperature of water, then because the molecules moving faster pushes them further apart, then the density will decrease. Got all that? It's 3 steps. Huh? That's up to you. If you want the example in your notes, you can have that. Okay? So I'm using this form right here I gave you. And I'm writing my hypothesis based on that. Okay? If I increase the temperature of tap water, if I increase the temperature of tap water, hello? I think I do. Yep. Yeah. Oh, okay, sure. All right, Fernando, don't forget when we finish, you got to go to the guidance, okay? You have to go to guidance when we finish here, okay? All right. So if I change the temperature of tap water, then because the molecules are moving faster, they have to move further apart. I don't know what I said a while ago, but something about that, okay? Then, because they expand. As they move faster, they expand. Then the density, that's our dependent variable, and we put the density over here on our graph. Then the density will decrease.
Okay, what about the molecules? Because the molecules expand.
You tell me.
Density.
Because the molecules, and the molecules expand because they're moving faster, right?
Because the molecules move faster.
Molecules move faster and therefore expand. All right? That's making the full connection there. All right? You can word it your own way. Okay? And that's what I want you to be able to do. But you got to have those three parts. If that's your independent variable, then plug in your model, and then you're going to describe what your dependent variable is doing. Got that? Now that is a model. That is a hypothesis we can test. Can we test whether or not the density goes down as I increase the temperature? Yeah. Absolutely. Absolutely. Now, occasionally, and Einstein did this, hypotheses are proposed that can't be tested today. They can't be tested because the technology doesn't exist yet. Okay? It happens. But it's still not, but a hypothesis, to be a reasonable scientific hypothesis, has to be written so it can be tested. Got that? Any questions about that? All right. No? No? You don't have that? No? What do you need to know? I'm sorry. Okay, gotcha. All right. Hypotheses. All right.